Hello students, I hope you all are doing fine. So let us continue. Before that, I would like to let you know that I have uploaded the solution from the previous session homework problem. So let us continue with our new topic, that is limits of the form 1 to the power infinity. Alright. Now, so today I will be dealing with the problems that gives you the limit as 1 to the power infinity. Now 1 to the power infinity, as we discussed in our first session, is an indeterminate form and will be having a solution. Now how do you find the solution is what we are going to look into in today's session. Before that, let us understand that this is a standard limit that we have, that is limit x tends to 0, 1 plus x, the whole power 1 by x is equal to e. Now the most important thing to understand in this case is the same thing I can write as limit x tends to a. So this x can go to any point, okay? And 1 plus f of x. Now here you can have any function in x, but the condition is whatever function you have at this place, the reciprocal should be placed as in power. The another condition is for it to be having e as its limit is as x tends to a, your f of x should go to 0. In this condition, the value of the limit will always be e. So we should not limit our function to just x. In place of this, you can have any function, keeping in mind the power is the reciprocal of that, and you should have 1 plus. And here x can go to any point. With this, let us continue. Now, let us see the problem. Now, whenever you get a problem in 1 to the power infinity form, of course, you have a function and as a power. So, I took a general form for that. So, it is limit x tends to a f of x whole power g of x. Also, they have given that f of x goes to a1 and g of x goes to infinity as x goes to a. That means it is making 1 to the power infinity form. Now, let us see what changes we have done with the function. So I'm considering y to be this function. Now I'm adding and subtracting 1, which is not disturbing the whole function. Also, I am multiplying and dividing by f of x minus 1 with g of x in the power. The reason I am doing this is when I added and subtracted, because I need, so what I'm trying to do is basically I'm trying to make this function in this form. For that I need 1 inside, and in the power I need 1 of f of x. Now over here, if I need 1, I have to subtract. Okay, I'm doing that. Now this is the function that you get in place of x here. Now this same thing should be reciprocal in the power form, so I am doing this. Once I do this, I have to make sure it is compensated. So if I'm dividing, I have to multiply also. And that's the reason overall we have done. Okay. Now, next is what? Now I'm trying to make everything come together, which is going to give me the limit. So this along with this function, I know will give me e. So I am taking it inside and the rest I am keeping in power. Now one thing you have to understand is limit x tends to a f of x whole power g of x is equal to limit x tends to a f of x whole to the power limit x tends to a g of x. Because of this, I am able to rewrite this thing. Once I do this, the base is actually this. What's the value of this whole thing? It's e. Why? Because f of x minus 1 is going to 0 as x tends to a. You can see as x tends to a, f of x minus 1, what is the value of f of x? F of x goes to a, 1. When x goes to this, so it is going to 1 minus 1, that is 0. So it is satisfying this condition, and that's the reason I am able to replace it with e. And now you have this in the power, and on this side you have y. That means what? Whenever you get any problem of this form, I can always come back and write it like this. So they both are equal. This is what we need to do in the problems, which gives you 1 to the power infinity. So what you're supposed to do, let me tell you again. You need to write the function as e to the power limit x tends to whatever limiting value they have mentioned. You have to subtract 1 from the base and multiply the power. Alright. Now let me also mention how did you get this, because you will have a question that since we are doing limit, how can you say this is equal to e? So I make sure that in every session I even derive the things that's possible. So let us see. So let y be that value. It is again giving me 1 to the power infinity. Now see what I did. I took k as this. The inside part I took as k. Now I am taking ln on both the sides. So ln of a to the power m is m ln of that. So I have written that. Now when you observe, this is coming in the form of ln 1 plus x by x. Now I am applying limit on both the sides. I already know this thing, so I can replace it with this. So those who are new to my channel, I would suggest that you go back and see the previous video so that you know how did we get this. Yes, so now I got 1. Now if you know this, that limit goes inside. So if I have limit x tends to a ln f of x, then it can be written as ln limit x tends to a f of x. Now because of this reason I am taking limit inside. Now you know that this is working like a b over here, right? So this property you should know. Whenever you have ln b base a is equal to x, this is same as this. So I'm trying to bring it to that form because now I need this value, right? I need limit x tends to 0 k. That's what I'm worried about now. So what I will do here is, so I will take now, this is with base e. So it will give me e to the power 1 will come here and this will go to that side. So the value, this is same as y, is e, and that's the reason this value is e. I hope it's clear to you now. So this is the standard limit. With respect to this, now we change the limit. Now let's come to problems quickly. So you can see the question, you can pause and try it by yourself. So this is limit x tends to 0 1 plus sin x whole power 1 by x. Also the condition which we already know is sin x goes to 0 as x goes to 0 and 1 by x goes to 0. Infinity as x. So as x tends to 0, 1 by x goes to infinity. Right? We already know this. So I can very well tell that it is in the form of 1 to the power infinity. Now without thinking much, you just try to convert into the form that is mentioned. What you need to do, this is your base function which is working like an f of x. You need to subtract 1 from that and you need to multiply whatever is in the power with it. That's all. Once you do this, this 1 will get cancelled. You will be left with sin x divided by x. Now I know that this value is 1. So I will get y as 1. It's very easy problem. The only thing is you should know some functions, simple function, and then we can apply. Coming to the next problem, have a look at this. What's the value? Now when you apply, please don't apply infinity here and say that it is infinity by infinity whole power infinity. That's not how we deal with limits. This is not making any form actually. So how do you solve polynomial? If you remember, in the first session I have mentioned already. Yes. First of all, you need to take x square common. Once you do that, you will see that when you take the limit, everything goes to 0, right? And you will be left with 1 to the power x. When x goes to infinity, you will get this form. So this is giving me 1 to the power infinity form. Alright. Now let's see how do you deal with this problem. So of course this is the base, you need to subtract 1 from it and then multiply the power that you have over here with the function. And then you can of course take LCM. After taking LCM, you will be getting this. Now what I know that the numerator and denominator has the same power and it is also going to infinity. I told you that whenever you have x in the function wherever and if x is going to infinity separately, then try to bring it into that form. Each term you try to bring, because I know that this will go to 0 as x tends to 0, x tends to infinity. So I will take x square common from this. When I take x square common, that I am multiplying with this x, okay. So I will get minus 1 minus 5 by x, and from same as denominator, so this x square will get cancelled. Here when you apply x tends to infinity, you can see this will go to 0 and this will also go to 0. So 3 terms will go to 0. You will be left with minus 1 by 1, that is minus 1. So this is the value for that. So this thing please keep in mind. You cannot apply just infinity, you have to bring it into this form. Okay. Coming to the next problem, have a look at this problem. So for doing limits, you should be good with all the concept. Even we have matrices and determinant in limits. So that property also you should be good with. And trigonometry, of course, you have to be very good with it. Basic functions, greatest integer functions, signum function, all this function you should have a basic idea, at least the graph of that. Now here I have a trigonometric function and the limit is going to non-zero term, which is pi by 2, pi by 4. Now when you apply limit, you can see it will go to, where will tan x go to? It will go to 1, and this will go to 2 into pi by 4. What is 2 into pi by 4? It is pi by 2. And you know that tan pi by 2 goes to infinity. Goes to infinity, but the value is undefined. But the best part is, here we are concerned about tending to. So it tends to infinity. So you will get 1 to the power infinity form. Now let's have a look how we have done this problem. So what I have to do, the first thing is I have to subtract 1 from the base. Bring the power in the product form. Now once I do that, I can observe that still when I apply the limit, you are getting actually what? This is getting infinity, this is giving you infinity, and this is giving you tending to 0. Right? Again you are getting an indeterminate form, so I need to simplify it further. Now I can see that here I can see tan x and here I can see tan 2x. So try to bring everything with the same argument. So I know that tan 2x is 2 tan x divided by 1 minus tan square x. Once I applied this, and whenever you see anything of the form a square minus b square, always try to think of splitting them if there is a factor in the numerator as well. I can see that there is a tan x minus 1, and here I have 1 square minus tan square x. So I am splitting them into a minus b into a plus b. Now I can see the terms are not same, so I will take minus common, which I am writing over here, and then it will get cancelled. Now you will be left with this minus I have taken outside. So now the best thing is you have to keep in mind is this is not creating problem 1 plus tan x. 1 plus tan x is not creating problem anywhere because 1 plus tan x is a finite value. Right? Where is it going? It's going to 2 when x tends to pi by 4. So you don't have to disturb this term. You just keep it as it is. Don't disturb. You have to only be concerned about the terms which is creating problem, not giving you a finite term. Alright. Now I will be left with this. Now you can see this value also exists, this value also exists. So I will just apply limit. After applying limit, you will be getting minus 2 by 2, which is minus 1. So the value is e to the power minus 1. Let's have a look at this problem. Again, it's involving some trigonometry and some algebra. Yes, let's have a look now. Now you can see as x tends to a, I can see it's going to 1 and this value is going to infinity. You can apply. When you apply x as a here, so a will get cancelled, you will get pi by 2, tan pi by 2 goes to infinity. So it's in the form of 1 to the power infinity. So we don't worry about much, we will go with our method, subtract 1, multiply the power. Okay, simplify it. Now this is what I get. Now what's happening is, when I apply x tends to a, this is giving me 0 and this is giving me infinity. So I'm getting like this again an indeterminate form. So what I will be doing here is substitution. I will go with substitution because by looking here I cannot think of any other replacement. If you can think of, you can surely let me know in the comment section. So here what I will do is I will take t as x minus a. So either you can take a minus x or x minus a, both will work. So now when x tends to a, you can see t tends to 0. So change everything over here. Now I have to replace this value. So for replacing this value, what I am doing is I am dividing this by x throughout, and also x is going to a here, so I can divide it tending to. And then what's happening here? This will be 1, so I got this value which is same as this. Now but again I have to replace x in terms of t. So again from this equation I will be taking t as t plus a. So this is what I will be replacing over here. And then here I have a x term which I will be replaced by t plus a. Okay, now let us multiply this inside. So you will get pi by 2 plus pi t by 2a. Now whenever you have tan pi by 2 plus theta, that is nothing but minus cot theta. We know that, right? So I'm just replacing it here. Minus is here, and this is same as t by t plus a. Now we prefer to always convert cot into tan because I have a standard formula. Okay, so let us do that. So cot can be written as 1 by tan, which I already wrote. Okay, and this t plus a I am taking it here. This t I am keeping here as it is. Now if I have to apply this limit x tends to 0 or tan x by x is equal to 1, I have to make sure whenever limit tends to 0, this function, this also goes to 0, in the sense that if limit x tends to a, then tan f of x by f of x is 1 only when f of x goes to 0 as x tends to a. This I have to keep in mind. Now let's see if it's happening. As t is tending to 0, where is this argument going? It's also going to 0. So yes, I can apply. So I will multiply by pi, I will divide by pi, I will divide by 2 pi, and I will multiply by 2. I have compensated everything. Now this part which is marked in orange will go to 1 as limit tends to t tends to 0, and this part when you apply, this is not creating a problem again, so don't touch it inside this. Now t tends to 0, you apply, you will get a. So you will get minus here, from here minus 2a here, pi, and then a will get cancelled and you will be left with this. Okay, coming to the next problem now. It's again involving sine and cos, basic trigonometry. So whenever I see sine, I always think of sine x by x form. Okay, so in this what we are doing is I will get 1 to the power infinity. You can check it, it's very easy. Now let's see what we are doing is, so I am directly going and applying the formula e to the power limit, subtracting 1 and multiplying it with the power. Now once I do this, I know that sine square x minus 1 is cos, because I know that what sine square x plus cos square x is 1. So sine square x minus 1 is minus cos square x. So this x can be anything, okay? So over here the x is this argument, so I have replaced it with this, minus I have kept outside. Now what I am going to do now is I will take these two terms in the product and keep it as a square. You know that, right? If you apply a limit, for example whole square, limit x tends to a, this is same as limit x tends to a f of x the whole square. So let me just find for single and then I will square it. So I have just find limit for cos of this function into sec of this function, right? So that's what I have written. So this sec now I am writing as 1 by cos here. Okay, now let's see what we are supposed to do. Now I have converted cos into sine. How do we convert? I will write sine pi by 2 minus the same argument, which is nothing but this, and the bottom also I have done the same thing. Now when you observe that this thing goes to 0 as x goes to 0, I can go and apply the formula as this, right? So what I have to just do, I have to just multiply and divide with the argument. That's what I have done. Here I have divided, here I have multiplied. For this thing also I have multiplied, here I have divided. Let me tell you that limit x tends to 0, sine x by x is same as limit x tends to 0 x by sine x, and that's 1. Okay, so that's why this second thing is also giving you 1. So when you apply the limit now, the first thing will also give you 1, second thing will also give you 1. Now the last thing is, that's what you need to deal with. Okay, now the last thing, see what we are trying to do. Now if you apply the limit directly to you, you will be getting 0 by 0 form. So to get rid of 0 by 0 form, now see what I am doing. I am taking LCM in the numerator as well as in the denominator. You can see I took here and then I did the reciprocal. So you got it over here. So you simplify, now you'll be getting this final term. Now when you apply limit at this, you will get 2 by 2 multiplied with a by b. 2 will cancel, you will get a by b. Now you remember what I said, you took only cos of this into sec of this. But while taking limit, you have to do whole square, and this minus also you need to consider. So it's minus of square of this term, and e is the base. So this is the final answer. I hope you understood. Let me show you the whole answer. You can always go back and watch the video again. So it involves a little bit more algebra. It's just because you are thinking that this is looking huge, it's very difficult. It's not. The argument is the thing that you're multiplying and dividing, and that's quite big here. The problem is easy. Okay, now this problem I would like you to try as an homework. You can see it will be done in the similar way, and I will be uploading the solution of this also soon. I hope you understood. Let me quickly go back and revise. So in today's class we learned how to deal with problems that is giving you the form of 1 to the power infinity in limit problems. So for this we made use of a basic thing, that is limit x tends to 0 1 plus x the whole power 1 by x is e. Now whenever you get a problem of this form where limit x tends to a f of x whole power g of x and it is giving you 1 to the power infinity form, you can write it as e to the power limit x tends to a, limit won't change, okay, for the first time, and then you have to subtract 1 from the base and multiply the power, and then you do your normal limits which you have already done. This is just to get into the form. After that you deal normally with the limits, and then we solve problems involving algebra as well as trigonometry, and also I start with the problems involving limits going to 0 and then infinity, some finite number as well. So I've dealt with 3 different types of limits over here. We did the substitution method also, right? Here we did substitution method. In few problems we did trigonometry, we involved trigonometry. Okay, so I hope you understood today's session. Please like, share and subscribe.